Hello everyone, I am Kurt Ballesteros and we are here today to help you understand one of Isaac Newton's law of motion. But first, who is Isaac Newton? Well, Isaac Newton is a famous English physicist and mathematician. He was the culminating figure of scientific revolution. He was credited with developing calculus, and he discovered the law of gravitation and a lot more, including the law of motion. But before we begin, do you know what the formula of inertia? Well, the formula of inertia is right here. So I equals L divided by the lowercase omega, or the weird looking symbol right there. Yeah. So I stands for inertia, while L means angular momentum and omega is for angular velocity. Anyway, let's now talk about the first law of motion. Myrene will tell you more about what it is. Myrene, it's up to you now.
Thank you, Kurt. Seems like you want to know what Newton's first law of motion is. The first law of motion, also known as inertia, states that an object at rest stays at rest and an object in motion stays in motion with the same speed and same direction unless acted upon by an unbalanced force. Let's focus on an object at rest stays at rest unless acted upon by an unbalanced force. Here's an orange. As you can see, it is at rest. Now, if I add a bit of force to this object, such as by pushing it, it moves. It is no longer at rest. We can say that this object was at rest. However, the movement of pushing this is the unbalanced force, and so it moved. If we now take a look at the thought that an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force, this is an example. If I swirl the water with yarn and I remove my spoon from it, it continues to spin. However, if I do it again and I shake the cup, the action is disturbed because the shaking is the unbalanced force added to the motion. Those are examples of an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Elmer, would you like to add anything?
I sure do. The law of inertia also states that matter wants to resist any change in the motion. That's why the speed or velocity of an object will not change unless acted upon by an outside force. To demonstrate this, I have a little experiment for today, the RC car experiment. To be able to do this, you will need a remote-controlled car and something that can act as a passenger of the car. You will attach the object to the back of the car. In this case, I will use a camera. The car will then be moved forward at high speeds without stopping. After a few moments, the car will be brought to a full stop. The camera or the passenger behind it moves forward abruptly as an effect of this stop. How does this work? When the car starts to move, the camera should move backward a bit because it remains at a state of rest, being pushed by the walls of the car. The camera would continually move with the car until it went to a full stop. The car stops entirely and the camera should move forward this time, potentially toppling over. Because of inertia once again, the camera remains at a state of motion and continues to do so until stopped by the walls of the car. And that is how the object resists the change in motion with the understanding of inertia. Elijah will now tell us about the history of inertia.
We now move on to the history of the discovery of inertia. Galileo Galilei deduced this from his experiments with balls rolling down inclined planes. He wondered how the Earth is spinning on its axis and orbiting the Sun, even if he didn't sense that motion. Newton came with the answer that since we are in motion together with Earth and our natural tendency is to retain that motion, Earth appears to us to be at rest. We have unbalanced forces acting on them such as friction and air resistance.
Today, I have prepared an experiment for you. It's called penny on a card experiment. In this experiment, you will need a small cup, a plain card, and a coin. Now that we have all the materials that we need, we can now start our experiment.
Step 1.
Put a card on top of the cup. Step 2. Put a coin on top of the card. Step 3. With a sharp flick, hit the card out from under the coin or pull it really quickly toward you. So, did you see the coin drop into the cup? Now, how is this related to inertia? The coin has inertia, meaning it really wants to stay in one place. If you move the card slowly, it isn't fast enough to overcome that force. If you flick it quickly, the coin stays in one place and then drops into the cup. According to Newton's first law of motion, a body at rest will remain at rest, and a body in motion will remain in motion unless acted upon by an unbalanced force. The coin atop of the card is at rest and will remain at rest. But since we flicked the card, it moved and fell down. The flicking of the card is the unbalanced force that acted upon the coin at rest. But did you know that inertia can also be seen in our households? Aaron Listed will tell us more about it. Aaron, take it away.
Inertia is not only seen in experiments and roads, but it also seen in the comfort of our homes. Here's an example. It is a ketchup bottle. Since most of the ketchup is settled at the bottom, if I tilt it upside down and tap on my hand, the sauce will fall. Now, how is this inertia? Since the sauce is at rest at the bottom, the bottle, I tapped in my hand, which is the unbalanced force. The ketchup is no longer at rest. I know there's a lot of inventions created from inertia. Valencia, would you like to tell us an example of it?
I sure would. A lot of inventions are made with the concept of inertia, one of which is the seatbelts. Seatbelts hold passengers down, protecting them from their own inertia. If a car hits the wall as it moves in a straight line and at a constant speed, there is a high chance of an accident since the car will apply force to resist the unbalanced force. With that, the passengers might bump his or her forehead on the dashboard. Seatbelts also help the passengers on bumpy roads. Here's a little demonstration of how inertia occurs, and it is called the coin drop experiment. You can do this experiment by having a glass that has a card or stiff paper on top of it. Next is, you get a coin and put it at the center of the glass and the card. Make sure the card or the paper has an edge for you to grab on or to flick on. Now, you must do this very swiftly or the experiment will fail. You must remove the card quickly or flick the card as fast as you can. Now, you can challenge yourself by increasing the coins. Inertia is seen in this by the means of gravity acting as the outside force in order for the coin to move and drop inside the glass. Flicking the card does not move the coin since there is not enough friction between the coin and the card for it to move with it. Kurt, do you have anything to add?
Of course, Aaron. Inertia states that an object at rest stays at rest and an object at motion stays in motion, with the same speed and the same direction unless acted upon with an unbalanced force. And matter wants to resist any change of motion. This process occurs everywhere, at home, when you're driving, when you're riding a vehicle, playing sports, and a lot more. The last demonstration that we have for you is very simple. It is named the sliding notebook experiment. This experiment can be done by simply finding a smooth surface, maybe a floor or a table. If you put the notebook flat to the ground or the table, do not move it. It is at rest also. But by sliding it to the other side, it is not at rest anymore. And wow! You have made inertia come to life. This is related to inertia because I have applied force to the notebook and it has the same speed and the same direction of the force I have applied to it, unless and an unbalanced force acted upon it. This is perfect example of showing how an object can move without a disturbance of an unbalanced force. This follows the part of the law which states, an object in motion remains in motion. Is that all, Elijah?
That sums up our presentation of Newton's first law of motion, inertia. Always remember that this law states an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. I hope that you now know the discovery of inertia and in what situations is it present. Always remember that science matters. Thank you for listening.